Hi everyone. Today we'll be discussing the LeetCode problem of the day, count covered buildings. So here you're given a positive integer n, which represents n cross n city. And you're also given a 2D grid buildings, which represents the x and y coordinates of each building. And all the buildings are unique. So a building is covered if there is at least one building in all four directions, that is left, right, above, and below. You just have to return the total number of covered buildings in the entire grid. So suppose we have buildings like this. So if we see this building is covered because there is a building in the top direction, there is a building in the bottom direction, there is a building in the left, and there is also a building in the right. So if there are buildings in all four directions, so this particular building is covered. In this example, we can see that only this building is covered and all the other buildings are not covered. Suppose if we take this building, it has a building in the bottom direction, but it doesn't have buildings in this direction. So this is not covered. Let's look at the input. So in the first example, we can clearly see that only the building at 2, 2, 2 is covered because there is a building in all four directions. So the output is 1. We go to the next input. Here we can see that no buildings are covered because suppose if we take this building, there is a building on top, there is a building on left, but there are no buildings on right and bottom, so it is not covered. And similarly, none of the buildings are covered, so the output is 0. And finally, for the third input as well, this building is covered because it has buildings in all four directions, so the output for this input is also 1. Coming to the constraints, the number of buildings can be up to 10 power 5, and the building's value, the coordinates x comma y, will be in the range from 1 to n, and all coordinates of the buildings will be unique. Now let's go over the approach. Suppose we have this set of buildings and this is the buildings on the graph. Let's look at all the buildings that are covered in this example. So we can see that this building is covered because it has a building in all four directions. And similarly, this building is also covered, all four directions. And finally, this building is covered. It has a building in all four directions. If we look at this building, it has a building in top direction, bottom direction, right? But it doesn't have a building on the left. So that's why this building is not covered. So totally only 3 buildings are covered out of these 14 buildings. And let's see how we are deciding whether a building is covered or not. So suppose let's pick this building. Its coordinates are 3, 3. So for this building to be covered, like we discussed, we need to find a building in all four directions. So in the top direction, the coordinate will be something like 3, y, where y will be greater than 3. So that then only it will be on the top of this building. For the bottom building, the coordinates will be something like 3, y, where y will be less than 3. Similarly, for the right, the coordinates will be 3, x, 3, where x will be greater than this 3. And in the left, there should be a building of type x, 3, where x should be less than 3. So from this input for 3, 3, we'll iterate on the all possible buildings and see whether all these buildings exist or not. So for that, we can take 4 Boolean variables. One is for up, one is for left, one is right, and one is bottom. So when we start iterating on this, and suppose we are at, let's say here, we reach this point. So this 3, 4 is satisfying this criteria. So the x coordinate 3 is same and the y coordinate 4, which is greater than 3. So that means a building on top is found. So the top variable, we'll just set it as true. Similarly, when we iterate on this building, 3, 1, the bottom criteria is fulfilled. So this is the 3, 1 building. Now for the left building, which is 2, 3. So when we iterate on the buildings, so when we are at this 2, 3, this criteria is also fulfilled. There is a building to the left. 2 is greater than 3. And similarly, when we iterate on this building, which is 5, 3. Yeah. So for 5, 3, we see that 5 is greater than 3. So that means there is a building on the right of this 3, right of this building. So once we iterate on all the buildings, we see that top, bottom, left, and right, all the values are true. So that means this building is covered. So what we did for a particular building, we iterated on all the possible buildings to find whether there's the building existing in all possible directions. So for one building, the complexity will be order of n. And since we have n number of buildings, the complexity would be order of n square. But like we saw, the constraints are 10 power 5. So n square will be too slow. So we somehow have to optimize it. Let's see how we can do that. Yeah, let's take the same example, which is 3, 3. Now for the 3, 3, we need to find a building in all 4 directions. So suppose, let's just focus on the top direction. So we need to find a building uh, which has a y coordinate greater than 3 and x coordinate should be equal to 3. So for this, the possible candidates are in this column. So let's just list out all the buildings in this, all the rows of this column. So we have row number 1, we have row number 3, then we have row number 4, and we have row number 5. So these are all the y coordinates of the building. So to find a building which is on top of this current 3, we just need to look in this array a value which is greater than 3. So we can see that 4 is greater than 3. So that means a building on top exists. Similarly, if you want a building on the bottom, we try to find a number which is smaller than 3. So in this array, we can see that 1 is smaller than 3. So the bottom building is also found. So the same thing will apply for the row as well. So let's first list out all the values. So this is column number 2, this is column number 3, and this is column number 5. Now, if you want this value, a building which is left of this, we need to find a building in this which has a value less than 3. So we can see that 2 is less than 3. So a building on the left exists. So that is this building. And similarly, we want to check whether the building on the right exists or not. So from this array, we will check a value which is greater than 3. So 5 is greater than 3. So this is also checked. So what we did is, instead of iterating on the entire array, we are just iterating on the particular column and also the particular row. But again, this can be time consuming because we are also iterating on the entire array and checking whether any element which is greater than 3 is present or any element less than 3 is present. So to further reduce the complexity, we can use a tree set to store these values. That means instead of this 1, 3, 4, and 5 in the array, let's have them as a tree set. Because in the tree set, we have a property that we can easily find the lower value or the greater value of the current number in order of log n time. So suppose I have a tree set with values 1, 3, 4, and 5. And I want to I can just do something like this. Reset dot lower of 3. So reset dot lower of 3 will find the first smallest number which is greater than 3 in this tree set. So 1 will be returned. And if we do tree set dot higher of 3, then this 4 will be returned. So in just login time, we are finding the top value, we are finding the bottom value, we are finding the left, and we are also finding the right value. But we haven't discussed how we got the tree set. So let's quickly do that. Let's erase it quickly. So before we start processing the computing the answer, we first process the entire buildings list to compute the tree set map. So let's have a map. This will be row map, and let's have one more which is for the column map. So in the row, the map will be something like this. Key will be integer, value will be a tree set. So that means if the key is 1, that means in the first row, I will store uh, all the x coordinates. So in the first row, sorry, this is the row hash map. So if the key is 1, that means we are at the row number 1. So on row number 1, we will store all the columns in a tree set. So in row number 1, the value will be a tree set, which will contain all these column values. Is 1, 2, 3, and 4. And similarly for row 2, the value is a tree set, and it will hold 1, 2, and 5. And for row 3, we have a tree set with the values 2, 3, and 5, and so on. And the same thing will apply for the column. So for column number 1, which is the column number 1, we'll store all the row numbers. So here we have a tree set with the values 1, 2. For row 2, we have 1, 2, 3, and 4. We have 4 values. And for row number 3, have 1, 3, 4, and 5. 4 and 5, and so on. So like we discussed, suppose the current building is 3, 3. So to get the row, we will look at this number to get the values 2, 3, and 5. So these are the values 2, 3, and 5. So from this, we can just get this value dot lower 3, that will fetch us 2. And this tree set dot higher of 3, that will fetch us 5. So left is present, right is also present. Now for the column, we will get on this key, this value, which is 1, 3, 4, and 5. So this is 1, 3, 4, and 5. So when we do this tree set dot lower of 3, then it will return us 1. So 1 is present. And this tree set dot higher of 3 will give us 4. So that means 4 is also present. So all 4 values are present. So we just increase our answer. Now let's code the approach. So first we'll be taking the hash maps. Key will be integer, the value will be tree set. So the same thing, we will take it for the column map as well. So we have row map and column map. So now let's just iterate on the buildings. Building in buildings. So we have x coordinate as building of 0, and y coordinate will be building of 1. So initially, we need to check if the x coordinate is present in the row map or not. So if the row map initially doesn't contain the key row number x, then we will simply add it. So row map dot put, and the value will be new tree set. And similarly, we'll do it for the column map as well. So initially, if the column number y is not found, we first need to add an empty tree set. So column map dot put x y. So once it is done, we need to add, so the current value is x comma y. So in the row map, we need to put the value of y in the tree set. So that means for row number x, we will store all the coordinates of y. So that means row map dot get x dot add y. And similarly for the column map dot add x. So after this for loop, all the hash map will be completed. Then again, we'll iterate on all the buildings to compute, to check whether all the buildings have all 4 buildings surrounding it. So same thing, x is building of 0, y is building of 1. So now we need 4 values: top, down, left, right. So we need to check whether a building is present in all these 4 directions. But before that, we need to get the tree set, the row tree set and also the column tree set. So the row, we can get it from the column map. Column map dot get of x, sorry, y. And we can get the column tree set from the row map. Row map dot get. So if we want to take an example again, let's say, let's pick a different example now. Let's take this value, which is x is 3 and y is 4. So for this 3 comma 4, the row should be something like this. It is column map dot get y. So in the column map for the 4, it will contain the values 2, 3, and 4. This is the column map. And to get the row, to get the column, we get it from the row map. So the row number is, the x coordinate is 3, and the values will be all these columns. This 1, 3, 4, and 5. We have 1, 3, 4, and 5. So this is the column tree set, and this is the row tree set. So once we got both of the tree sets, we need to check for the top. So top will be, for the top, we need to look in the column tree set, because this is the column tree set, and in this we need to check for the top value. So for the top, we'll just do column dot higher of y. be an integer. Similarly for down, we'll just do column dot lower of y. And for the left, we will get it from the row tree set. So row dot lower of x. And for the right, row dot higher of x. So once we got all the top, down, left, and right values, if none of them are null, then the current building is surrounded. So let's just check for the case. If top not equal to null, down not equal, and not equal to null, and right not equal to null. All if everything is not equal to null, then we'll discount the value. That means the building is surrounded. And at the end, just return answer. Submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, initially we are iterating on all the buildings and adding it in the tree set. So this is order of n, and inserting in the tree set will be of order of log n. So this for loops complexity will be NlogN. And the same thing here, we are again iterating on all the buildings, and for each building, we are getting the higher, lower values, and this will all be order of log n complexity. The total complexity of this for loop will also be NlogN. So the entire complexity will be order of NlogN. Coming to the space complexity, the only space we have created is this hash map, and if we combine all the values in the row map and column map, this will be exactly equal to the number of buildings. So the space complexity overall will be order of n. I also have the code in Python if anyone wants to view it. I'll add this in the description as well. And let's catch up in the next video.